My name is Otto Hager. I'm from a company called Biovest Holdings, and we are the inventors of what we call a third generation biogas plant. In simple terms, we managed to understand how a cow eats grass, converts it into all the different products, and that's what we are mimicking. As a result, we've got a plant which is not the traditional large concrete pot, but is containerized and is scalable. So you can go from one cow to a herd of cows, meaning that you can produce as little as 200 liters of diesel per day or up to a few thousand. And the byproduct, or the product we use as feedstock, is cellulose-rich material, which is a fancy word for any grasses or leftovers from agricultural crops like wheat straw or rice straw or anything like that, and that we can then feed the cow, and our cow eats it and makes gas. And then the gas you can then use as an alternative for hydrocarbon fuels, and then byproducts also food grade carbon dioxide.
What does the fact that it's scalable mean for small communities?
So scalable gives you the opportunity that you can start off with one unit, producing a certain amount of gas to do certain activities, to run a generator, give people gas to cook with, and so forth. And then once that system is in place, you can simply add to it. It's like, I always joke, it's if you like milk, you don't build a monster cow, you just get another cow, or a third cow, or fourth cow, and it's the same principle. So you simply can add on to the plant, and the same principle, same efficiency, but it just makes it much easier to do. Also, it's manufactured in a factory, so it's not manufactured on site with huge environmental impact issues. We manufacture in a factory under strict conditions, quality, quantity, etc. And then when you roll it out to site, there's very low impact on site, so much so that we don't even trick any EIA, what do you call it, like targets or anything. So we're well below the EIA limits, so we don't have to do a full EIA study, because we're not processing any waste or let's call it non-organic byproduct. It's all organic. It's basically like feeding a cow in a herd.
Tell us about the purple cow.
So in marketing, there's this concept that people get used to normal things. So we're all used to a normal cow. So you drive around the countryside, you saw a normal cow, and eventually you don't see the cows anymore. But if you suddenly see a purple cow, you'll say, wow, this is something different. This is something new. We have to stop and take a picture. So we believe that our technology is the purple cow for renewable energy, and that because people will see that it's different, we can label it as a purple cow and then get additional attention to that.
You've had some offtake in India.
Yes, so it was very interesting that we met somebody in the new virtual world through a virtual meeting. We wanted to buy cleaning equipment to gas scrubbing. So gas scrubbing is where you take the raw gas, clean it, and then you can use it as an alternative for fuel, diesel, petrol, etc. And the guy asked us what we do, and I explained him we've got a third generation cow that we feed grass and make gas. He was quite impressed. He came to visit South Africa, and then contrary to that, he then invited us to go to India. We went to India, and they've now given us a tentative order for 400, of which the first 4 needs to be delivered by the end of the year, which is a little bit of not a surprise, but it's a bigger response than what we anticipated. India uses a huge amount of liquid natural gas, in proportion about 10 times, very close to 10 times more than South Africa use. So they've got a target to replace 20% of that with what they call clean biogas, CBG. And we make raw biogas, which they can clean, and then they want to use it in the industry. So they've got a target to replace 5,000, and they're very keen on using our technology. So last month we had a launch with a whole bunch of the dignitaries and ministers, where we signed a technology transfer agreement, and we're busy working on the license agreements to export this technology.
That's amazing. Congratulations.
Thanks.
You were at Africa's Green Economy Summit, where you did a pitch for prospective investors. We're at an energy summit now in Enlit Africa, where you also did a pitch. How difficult is it to get funding?
I think think it's quite a challenge in the concept where I would say where solar panels was 5 years ago. So solar panels 5 years ago, you try to say to something, oh, I'm going to put this thing on your roof to make kilowatt hours, you're going to use it. And everybody says, yeah, okay, sounds logical. And then the event of load shedding happened, and everybody suddenly, okay, I need this. And now there's no two thoughts about it. And financing institutions understand it. They're willing to fund it, and they're willing to put the money into it. And that's the only way you can fund it, because nobody's got the capital up front to invest 100, 200,000 to convert your house. But now you can get a loan because the bank stands it. You can pay it over time. And I think we in the biogas industry, we can move that same direction. But to leapfrog is the challenge, and that's where we saw India as an opportunity. They've been doing it for 10 years. They understand the technology, the product itself. In South Africa, biogas doesn't have a very good name because there was a few, let's call it small test models built, and the quality and the standards wasn't that very high. So financial institution understands it, but they see it as a big risk because they haven't seen the offtake agreements, haven't seen commercial plants. So we saw India as an opportunity to learn from them, use their contracting, their funding, their structures and so forth, and then use that as a leapfrog to do it. So we hope that we can find some willing and eager investor, because it's definitely green, it's a renewable. So we're making the same thing as hydrocarbon fuels, but our fuel is just a few months or weeks old. So we harvest plant material that was growing 3 months ago, and we make the same thing, which is methane, which you will get if you suck the oil out of the ground, which was produced 4 million years ago. So carbon that's released through old material, that's what heating, causing, let's call it the planet heating, but ours are a circle. So it's new energy that we produce, comes from the sun, we just put it in a different context. So we're definitely looking for investors. We've got a pipeline of projects where we're taking agricultural byproducts like straw. So we're busy developing a project in Winelands where we're taking 8,000 tons of straw and converting that into equivalent of 3.5 million diesel liters a year, and then supplying that to the food industry to use as a fuel medium, replacing things like liquid paraffin or LPG and so forth. So giving a more cleaner, sustainable model. So we're challenging all the guys that really wants to go green to say that here's a technology that's scalable, it's movable. So should one supply point end up and you don't have feedstock, you can physically move the plant to something else, and feedstock is also not competing with food. I'm not taking anybody's food off the table. I'm using product that's nobody actually wants. They're using it as a bedding or burning it at the moment. So we can add value to that and then make a renewable gas from it.
What is your vision in terms of what biogas can mean for the energy sector in Africa and its development?
So I think there's an enormous opportunity for biogas for the simple reason it's a renewable fuel. It's a very high energy intensive fuel. So biogas consists of CH4. So there's one carbon and 4 hydrogens. So if you split that, you actually end up with 2 hydrogen cells. So everybody wants to go hydrogen, but the raw material is biogas. So you can go from biogas to hydrogen very easily, actually cheaper, much cheaper than using wind or solar or anything. Solar and wind has got its own environmental impact. Here's something really natural already in a gas going to the next step of gas, so that's easier. You can make sustainable aircraft fuel, SAF, you can make from biogas. So there's enormous amount of potential. In its raw form you can give to people to cook with. So you can run simple a stove, a fridge or a light from raw biogas, or you can upgrade it up to hydrogen. What is also the potential is the feedstock. The most abundant feedstock in the world is something called cellulose, which is grasses. If you just look around you, grasses, leaves, everything, that's cellulose. So we are blessed with the biggest volume of material. If you feed it to our cow, she can make the gas for you, and you get a byproduct that you can use as a usable, user-friendly product. It's modular, so we can put something down in a remote area, get them to harvest the feedstock, produce the gas, and then you can generate electricity, supply community from electricity, gas to cook with, a generator to run electricity, and then suddenly you can have a small economic hub up here. We've done quite a lot of research with Stellenbosch University, and also India supports that for each little biogas plant you put down, you can stimulate about jobs for about 500 people related to that biogas plant. Yes, the plant itself is small, but now you got somebody that's harvesting agriculture, he's planting, he's have to do maintenance, he's got a vehicle that's running on the gas, he's got a generator, he supplies electricity, so it becomes a very big multiplier. So we see it as a very green opportunity to actually multiply and get off-grid communities really developed. The comparison between solar is, so we build a solar plant, 5 megawatts. Once it's built, there's 200 people, no jobs anymore, because there's only one guy cleaning the panels. With biogas, all 200 must still work, because every day, every year, you must harvest, you must process material. It's much more sustainable, and in that sense, it's not very water intensive, so it's not like we're going to use all this water, and the material it's a natural product, so it's a natural loop that you recycle and put the byproduct, because in the plant we've got what we call nutrients, same as the cow's urine and manure. So that's a valuable feedstock that you can put back into the soil, improve the soil quality, produce more food. So it's a perfect what they call a circular economy model.